Okay, so number 6. A study of peach trees found that the average number of peaches per tree was 525. The standard deviation of the population is 140 peaches per tree. A scientist wishes to find the 90% confidence interval for the mean, so we want 90, right? What we were looking for. A scientist wishes to find the 90% confidence interval for the mean number of peaches per tree. How many trees does she need to sample to obtain an average accurate to within 18 peaches per tree? All right, so let's write down what we know. Study of peach trees found that so this is from a study, right? So that study found that the average number of peach trees, the average of that study, was 525. The standard deviation of the population, so this is the population mean, right? Standard deviation, the standard deviation of the population, that's sigma, it's 140. We want a 90% confidence interval. Confidence interval of the mean number of peaches per tree. And how many trees does she need to sample to obtain an average accurate to within 18? So we want plus or minus 18 peaches to be accurate within that. That's what we call our margin of error. Okay, so we probably need a formula here, right? We've got all these variables. We want to know how many trees. We want to know n. How many trees should this person sample in order to be 90% confident that they're within 18 peaches of the true population average? I'll say that again. How many trees does this researcher need to sample, scientists need to sample, in order to be 90% confident that they've got the true population mean to within 18 peaches per tree? Let's go to our formula sheet. I think confidence intervals is chapter 7. Here we go. So these are the two formulas to actually create your own confidence interval, right? Z is when we know sigma, the population standard deviation. T is when we do not know sigma, so we use S, the sample standard deviation. And then this third formula is the one I'm interested in. This is the sample size for means. N equals Z alpha over 2 times sigma over E squared, where E is the maximum error of the estimate, otherwise known as the margin of error. Maximum error of the estimate, that's the margin of error. That's the maximum error that we're willing to have, right? That's the maximum error that we're willing to accept. That's the word I was looking for. So let's write this formula down. So N equals the Z alpha over 2 value times sigma over E squared. This will tell us the number of trees she needs to sample, right? And this here is our E. Okay. Now I have a lot of I have sigma, I have the margin of error, I have squared, but I don't have Z. How can I find Z? See, I know I need the 90% confidence interval, right? So check this out. Let's go to our formula sheet. And then when we do this, I'm not going to use the Z distribution table. I'm going to use the T distribution table. Why? Because that has a confidence interval row. So I want the 90% confidence interval. And if I go all the way down to the bottom of this table, see, all the way down to the bottom, see it says Z infinity, that's the Z value I need. That Z value of 1.645 is my Z alpha over 2 value that I need for a 90% confidence interval. Okay? So that Z value is 1.645 times sigma, which is 140, divided by the maximum error of the estimate. We need to be within 18 peaches. I'm going to throw this into the calculator here. So in parentheses, 1.645 times 140 divided by 18, close parentheses, squared. 163 point, let's say 163.7, right? 163.7. Now, I can't have 163.7 trees, right? I don't know what 0.7 of a tree is. So you'll always round up. So 164 trees. So how many trees she needs to sample? 164. I'll say one more thing. If you look at the answer, the solutions for this problem, it says 165 trees, right? So I'll put that in purple. Solution on the review sheet says 165 trees. Now, I'm not saying this is wrong or this is wrong. They're both correct, but here's why that happened. When using the formula, right, if I go back to the formula sheet, right, I'm going back to, right, exactly right here. The confidence intervals. Remember 90% was 1.645. Well, what happened is, to create the solution, instead of using 1.645, they rounded to the 100th place. So they use 1.65, which is the value that's shown in the textbook. If you're memorizing these values, it's 1.65. It's okay. So if I put this into the calculator now, let's do second entry. And instead of 1.645, let's delete that one character. So 1.65 times 140 divided by 18 squared. I get 164.6, right? 164.7, was it? Yeah, 0.7, I should round up. And when I round this up, I end up with 165. So this, you'll get 164 if you use a more exact decimal for that z alpha over 2. If you round to a lower place, to the 100th place, then you'll get 165. They're both correct. I'm sure if this problem showed up and it was multiple choice on the exam, that you'd only see one of these or the other. So there you go.